Welcome back, everyone. I'm going to be hopefully editing video together, showing a lot of the process I've been developing to create synthetic sapphire. I found that creating synthetic ruby is actually quite a lot easier. Um, there's a lot less tolerance that you have to abide by to combine the chromium 3 oxide with the aluminum oxide. I've used anywhere from 1 to 5% chromium 3 oxide with the aluminum oxide, and the red color in the synthetic rubies that I've created is fairly similar. Um, but with the sapphire, I've had a lot of mixed results, and so far the only really nice blue crystals that I've been able to get in my starting bowls are I would say microscopic. So there's my microscope. So I tried a new formula. I believe it was yesterday, where I had decomposed some ferrous oxalate, which I made a while back. Um, I created the ferrous oxalate from ferrous chloride, and you combine it with oxalic acid and wait for the precipitate of ferrous oxalate, and then you just strain that off, and it's pretty stable to hold on to for quite some time. I've had this in the jar here for I don't know, 4 or 5 months now. But anyhow, I used the ferrous oxalate, and I created, this is some people just call it black iron oxide, but it's just iron oxide, and it's pyrophoric. Hence, I've got it clamped off here to prevent oxygen from getting inside. Once that gets into contact with the oxygen, it can ignite. And one of the cool things that you can do with it is pour it out of the container, and as soon as it touches, or as soon as it makes contact with the oxygen in the air, it turns into a shower of sparks, and it's pretty cool. Nerd Rage did a video on that, and I know I've seen a couple other people create videos. So anyhow, I've been experimenting with different formulas to create a good looking blue for synthetic sapphire, and yeah, I've been struggling with it, but I really believe using the iron 2 oxide along with titanium dioxide, it is going to be the key. And I'm putting it in a proportion of it'll be 98.5% aluminum oxide with 0.5% titanium dioxide and 1.5% of the pyrophoric iron. So once I get that together, I'm going to have to do this in an oxygen-free atmosphere. So my simple solution to that is filling up a 5-gallon bucket with carbon dioxide. And so I'm doing that with baking soda and vinegar. I'm going to let the carbon dioxide fully fill up the bucket, and then I'll be able to weigh out all my different oxide powders and combine that. Then I'll be mixing that up. I'm gonna put it in this little bucket here, which I've got full of chrome-plated steel bearings. I don't figure anywhere near enough chrome will wear off into the oxide powder mixture to cause any major contamination. If anything, it'll help the blue sapphire fluoresce under UV light. But due to the excess of iron I'll be using, I don't think that's going to be a problem. Uh, Having excess iron deposit, or excess iron ions within synthetic sapphire prevents the fluorescence from being apparent from the chromium 3 ions. So anyhow, I'll be putting together other videos of my process, but I decided I'd make a quick video on this. I've got a agate mortise and pestle here. I was planning on showing a little bit more of the process, but I don't want to make this video too long. But anyhow, I'm going to be doing all this under carbon dioxide and getting it all mixed up. Once the iron oxide is, or I'll say the iron 2 oxide is completely mixed with the titanium dioxide and the aluminum oxide, there should not be any issue with the pyrophoric nature of iron 2 oxide reacting with oxygen, because it's going to be mostly covered in the titanium dioxide and the aluminum oxide. So I did this the other day, and it worked without any issue. Unfortunately, after I got home from work today, I was gonna thoroughly mix the ingredients up into a very homogeneous mixture, and had a little accident and knocked my beaker off the table, and my oxides got everywhere and into the carpet and everything. Luckily it's non-toxic, and there shouldn't be much staining, but it was a huge disappointment because I worked really hard at purifying everything. What I am using is, this is 99.9% pure titanium dioxide. The aluminum oxide is 99.6% pure. And this is, I made this stuff here, and I had recrystallized the ferrous chloride into nice green crystals, and then so that really purified it, and then mixing it with the oxalic acid to make the ferrous oxalate. It's I don't know. I would say it's like 99.9% pure. I want to say 100, but I'm still quite the amateur chemist. Anyhow, this is what's going on with my activities lately. I just thought I would share what I'm doing and explain the process of where I'm at right now. I've tried using iron 3 oxide, which is, common rust, the red stuff. And I didn't really get too great of results. The sapphire crystals that I created were more dark gray. You could find some lighter gray blue ones among the mix. Pretty much everything that I've had to look at with the sapphire to get any visual cue of blue tones is under the microscope, whereas the ruby, I've got pieces that are a fairly good size that are, I would say, it's the pigeon blood red. So I'll be doing some more videos, especially with the ruby. It's definitely going to be a lot easier to show the synthetic ruby and creating that. I would say I'm about 20% done with creating my Verneuil furnace to create flame fusion corundum, and I'm so excited about this project. And anyhow, I just like I said, I wanted to do this quick little video explaining what's going on. hopefully my next video will be a lot more interesting. But in the meantime, I'll be working to get everything prepared, and then I'll be able to do some more tests to see if I've got the formula down, so I get the nice blue sapphire that I'm trying to create. So that way, once I get the Vernwell furnace running, and I have no idea if I'm pronouncing Vernwell correctly. It's anyhow, that's it for now. I'm going to cut the video off now. It's over 10 minutes. So thanks for watching. I hope I've got some interesting stuff to show you guys in the future. I know the ruby is definitely interesting. I just don't know if my camera is going to ever be able to capture the fluorescence. It's unbelievable how much the ruby fluoresces, and I'm hoping that I'll be able to get some of the sapphire to fluoresce, but it's not a property that I'm trying to give the sapphire. It's just something, a little extra. If it happens, it's cool. If not, oh well. Anyhow, that's it. Thanks, guys.